In this tutorial, we're going to look at how you can use geometry defined in Rhino in your Grasshopper scripts. This is one of my favorite things to show new learners of Grasshopper because I think it opens a lot of doors. I think it's common for beginners to think that they have to, if they want to build a complex model in Grasshopper, that they have to model the whole thing using a ton of sliders and building every point and every polyline and so on. And the fact is you don't. Even in production, you really want to rely on geometry in Rhino when it's appropriate. So let's see how this works. We're going to launch Grasshopper, and what we're going to do is, first I'll just hide everything that I have here. The kind of common process for loading in a piece of geometry in Grasshopper from Rhino is to find the corresponding param type that holds that geometry. So what do I mean by a param? These things, these kind of black hexagons that I've alluded to elsewhere in this series, are params that hold a certain kind of geometry or data. So under the geometry params we can represent a circle, a curve, a plane, a line, a rectangle, a box, a mesh, a surface, a B-rep. And there are also non-geometric parameters like colors and GUIDs and booleans and numbers and things like that. But for our purposes, I think we really care about the geometry parameters. And usually the ones that we're going to use for reference are either curve, which will also incorporate things like lines or arcs or rectangles, mesh for any mesh geometry, surface for any sort of single surface geometry in Rhino, and B-rep, which stands for boundary representation, which is one of the few places where Grasshopper's nomenclature diverges from that of Rhino. A B-rep is basically a polysurface. It's a collection of multiple surfaces. So when you build something like a box in Rhino, actually I think a box becomes an extrusion, but there anything, if I Boolean this out, let's say, this is a polysurface. So you can see one polysurface added to selection. That is a B-rep. You can also use the B-rep parameter to reference things that are extrusions. If I select this, it says one extrusion. So what we're going to do in order to load something in, let's start with a curve. I'm going to draw a rectangle in Rhino. And I'm going to grab a curve parameter. And I'm going to right-click and choose Set One Curve. And this is a little different from what we've seen before with Set One Point, where I actually draw the thing. In this case, it's asking for a reference. In fact, there are ways also to do other things like copy, but for the most part, you almost always want it to be reference. So when it's asking for the curve or edge to reference, I'm going to select this curve. And it looks like nothing changed, except this component is now gray. And if I select it, it turns green in the Rhino viewport to tell me that it's Grasshopper selected. So what that means is that I can now do things with this, like I can measure its area. So if I go to Curve Analysis and go look for area, where is it? Maybe it's under Util. Where does area live? It's probably, here, it's under surface analysis. In that case, because the same area component can be used for curves or surfaces. In any case, I'll plug this in, and I'll use a panel to look at it. And now I've got a live area readout of my curve. And the nice thing is that this retains a dynamic link to this geometry. So remember I said before, if you bake something from Grasshopper into Rhino, it loses its parametric connection to your script. But if you go the other way, if you take geometry from Rhino and bring it into Grasshopper, it maintains its parametric relationship. So that means if I change it, if I modify this curve, the area is going to update automatically. And that also means I can do all kinds of geometric operations with it, like I can fillet it, let's say. So I can take this curve and fillet it with a radius of 20. And now I have this sort of dynamic filleted piece of geometry that has sort of a perfect arc radius. This is already really useful in and of itself, because what happens if I take this geometry and I fillet it manually, let's say, in Rhino with a radius of 20. And I'll fillet it. And it wants me to pick all the corners, right? We'll do fillet corners actually and say 20. That's the, oh, it doesn't, it won't even let me in this case because that's too big. But let's choose a smaller one. Now this has added all these control points. If I just wanted to change the like original edge, it's lost to me. I don't have the information about where this came from. Whereas over here with the Grasshopper generated fillet geometry, I still have these kind of nice lightweight for control handles, but I'm still getting the kind of perfect filleted geometry as a result. And I can just keep building up a definition on top of this. I can extrude it. I'll use a Z vector with a magnitude of 40, let's say, and I'll cap it. I'm improvising here, but effectively I've built up some complex 3D geometry, but this simple 2D geometry referenced in Rhino is driving all of that geometry. So that's a really nice thing to be able to do. So in addition to being able to explicitly reference individual items, we can also reference items automatically. So for the most part, Grasshopper doesn't know anything about layers. So it doesn't really matter what layer you put something on, but in this case it does. So let's say I'm going to create a layer and I'm going to name it Grasshopper Geometry. And on this layer, I'm going to draw some lines. And what I want to do is reference any line that's drawn on the GH geometry layer. And I'm going to use a component called the geometry pipeline, which is under input, I believe. See, I never know where things are because I always search for everything. But we can, it's a param, that's why it lives right here under params geometry. And for those of you who didn't catch in the earlier tutorial, if you have a component on the canvas and hold down Control Option, you can see where it lives in the toolbar. So this geometry pipeline is a little bit different than other components we've seen. It wants a layer, but it doesn't actually have inputs. So I have to actually edit it via this interface. I can say GH geometry, and I have to make sure this matches exactly the name of the layer that I specified. Again, hit enter this time. And it wants to know what type of geometry it should consume. So it's going to want curves. So I'm going to double click this, which represents curve geometry. Now, I'll see that I have a list of these lines, and they've all been referenced in. They've turned red over here. Actually, the layer is red, but in any case, if I select them, they're green. And if I wanted to, say, create a loft from these, I could. And I still just have these individual curves. And the nice thing is, if I were to draw a new line on this layer, it would get added automatically. So this becomes a really powerful way to kind of build up a kind of custom, more advanced drawing routine for yourself, where you want to kind of do simple and easy things in Rhino and let Grasshopper handle the kind of repetitive steps of the process. Now, the one thing to be aware of with this is that the order of your geometry is not always predictable. So as soon as I move something, it actually changes the order in the list, and we can see that's not what we want. So it's common to want to take geometry that you've referenced from Rhino and then maybe sort it or organize it in a fashion that makes sense. So in this case, I kind of want these to be sorted along the x-axis. If I view this in the top view, I see that if they kind of went from least x to most x, then my loft would make a lot more sense. So it's common to want to do a list manipulation on some of the geometry that you referenced from Rhino. So we're going to use another list operation that we haven't seen yet called sort. And we're going to use sort list. And this component takes a little getting used to. It has a k input, which is the thing that's getting sorted. And then it has an a input, which is a parallel list of things to sort along with it. So what does that mean? Sortable things are things like numbers. In fact, it really does want a number as the key. But what if you wanted to sort lines, like in our case? Well, if I just sort these lines, it's going to do something, but it's going to spit out numbers at the other end. In fact, what it's doing is trying to convert these lines into lengths. So it's sorting them by length, which is not what we want at all. Instead, we want to get the x position of this line. So how can we do that? Well, the first thing is we're going to need a point on this line. So in this case, let's just use the end point of the line. So I'm going to go to curve analysis. I can use either curve middle or endpoints. Actually, let's use curve middle. Why not? So you can see this is generating the curve middle. And then I'm going to get the x coordinate of the curve middle. So for that, I'm going to use the opposite component to one we've seen before, where we were constructing points from numbers. If we deconstruct a point, we can get the numbers back out, which are the coordinates of it. So I now have an x coordinate for each one of these points. And this is what I want to sort. So you can see if I look at these lists, I'm going to double click and type a quote mark, which is a quick way to get a panel. I've probably already done that in this tutorial series without even explaining it because it's such a habit to me. I'm just constantly creating panels on the fly in order to inspect data. It's a good habit to get into. And you can see before it goes 3, -4, 1, 24, and so on. It's not sorted in order. Once it comes out the other end, it is. But the purpose of this second input, this A, is to take some other parallel list. And when I say parallel, I mean a list having corresponding items. So there are 7 x coordinates because I have 7 curves. So the list of curves themselves is a parallel list that I actually want to sort. And so now, it's hard to tell from this panel because these all just say reference line like curve. But what it is doing is reordering the list that goes into A according to the keys that go into K. So it's this whole operation basically says take the curves, get their midpoint, get the x coordinate of their midpoint, and then sort the original list of curves by that x coordinate's numerical value. It's easier to see this if we just plug it in. We can see that now, no matter how I make manipulations here in the Rhino viewport, it's always going to sort them in order, and the loft that comes out is always going to be, kind of an appropriate one. The one other thing I'll add to this Rhino reference workflow is that I've written a plugin called Human that really expands the capability for Rhino to interact with Grasshopper and vice versa. So if you're interested in this, I highly recommend installing it. The way to get it, there are a number of ways. You can go to Food for Rhino. The way I recommend getting it is using the package manager, which is kind of a hidden thing in Rhino 6 because it's fairly new, but you can still access it by typing the word test package manager. You have to type it exact right. It looks like it's not going to work because it doesn't show up in the autocomplete because it's actually like a secret command. But if you hit enter, it will launch a package manager interface. And you can go look for plugins. And so if you type human, not spelled like my name, and grab human, you can hit download and install. I won't do it now because I already have it installed. And this will add that plugin to my Grasshopper workspace. If you're in Rhino 7, the work in progress build, or if by the time you're watching this Rhino 7 has come out, you can just type package manager, and that will work too. But in Rhino 6, it's a hidden command, so it's hidden behind this test interface. Test package manager. And you can install whatever plugins you want. This is also a great way to find out about new ones, although right now you'll probably find more plugins that are available on Food for Rhino than here, but more are getting added every day. So once you have human, let's find it over here. There it is. So human creates a tab that looks like this, and it introduces a component that's relevant to this discussion, which is almost the same thing as the geometry pipeline. It's called the dynamic geometry pipeline. And really the only critical difference is that instead of entering these values into the pipeline here and clicking these buttons to specify the type, you can do so by typing actual values. And this is useful because you might want to flip through multiple layers. So we can also use the layer table from document info and another special component that deals with lists called the item selector, and grab a list of all the layers, which comes out of the layer table, put it through this, which allows you to pick a single item from that list. So I can say, actually, give me all of the lines on GH geometry. plug that into my layer input, and then I also have to specify the type I want, which in this case is just the word curve. So I'm using that same shortcut again to create a panel, but this time I'm doing double click and type within quotes. I'm going to type the word curve, and it's going to create a panel automatically populated with that information for me. So I'll plug that in, and this is now going to get back the same list of curves that I had before. One more little nifty trick. If I want to rewire all of these things from this output to this output, I can hold down, I believe it's, let's see, Control Shift, and then I can click on this bundle of wires and drag the whole thing over. And the nice thing about this is that if I have like a different set of lines that I want to loft together on a different layer, like this, then I can just pick that layer instead. I put those on layer 2, and it's going to apply the same operation. So this is kind of a nifty, more advanced workflow for kind of quickly switching between sets of input geometry for your Grasshopper definition.